Index numbers is our new topic that we are going to cover, but please don't forget to subscribe to the channel. Now, index numbers, there is a definition and there are quite many, but we are going to be on specific here. So, what's the definition of an index number? So, if you don't call them index numbers, you can call them price indices. So, an index number is a statistical measure that shows a change in a given variable over time. So, the common words we are going to find here are base year, then the current year. The base year is denoted with P naught. This is a year against which all other years are compared. So, it's like the old year before. Then current year, this is a year for which an index is to be calculated. Index numbers include the following. So current year, P1, then base year, P naught. So we have the simple index numbers, which some people call the price relatives. This is a measure. This measures the relative change from a base period for a single quantity. It can be calculated by simple index number is given by P1 over P naught. P1, we say is the price in the current year. Then P naught is the price in the base year. Times 100, we express them as percentages, all of them. So then there is what we call the simple price index. This one is simple index number or simple price relatives. This one is simple price index. This is an average of price relatives of given items. So what we do here, we get the P1 over P naught times, express them percent, but we divide them by the total number of items we are calculating the price relatives for. So here, the difference here is, we just here we sum these ones and we divide by the number of items we have. Then the simple aggregate price index can denote it, or we can identify it with that acronym. This is a ratio. This is a ratio total. This is the ratio of total prices of items in a given year to the total price of items in the base year expressed as a percentage. So here, what we do to get a simple aggregate, we sum the prices in the current year over the sum of the prices in the base year times 100. Then weighted price index. This one I am introducing in the idea of weight. What does weight say? This is used to calculate indices of numbers with more than one item in comparison. It's given by, this is WI. This shows that we are getting the weight times the price relative. You know that the price relative is given by Pi over P naught. So you get this times the weight. Then express it as a percentage. Okay, where this is now note that the WPI, this weighted price index, is sometimes called the weighted average price index. So when you see this, in simple terms, they mean this. Let us go to composite index. This is the measure. This measures relative changes from a base period for cross-related items. So this is the formula that we use to get the weight times the price in the current year over the weight times the price in the base year. Now the weighted aggregate price index, WAPI, this can be obtained if the weights or quantities of commodities are given. You see that the formula is the same here. In simple cases, that this can be calculated as weighted aggregate price index. Now, if they give you quantities both in the current and in the base year, you get the sum of the prices and their quantities in the current year over the price, the product of the prices and their quantity in the base year, the sum, the total, then you express it as a percentage. This side I've talked about it. Then if the index number is 100, if you calculate, maybe when you calculate this, you get 80%. It means that it's below 100. It means that there was a decrease. Then if you calculate that it's above 100, say you get 130%, it means there was an increase. How do you get that increase? You get 100, you get the B minus 100 if it's C. Of course, if it's an increase, the index is going to be bigger than 100. So you get 100, you subtract it from the index. Then if you have a decrease, you get now the percent, the 100, then minus that index, so that you avoid a negative. So you always subtract smaller thing from a big thing. So that's it. Now we are going to see examples on how to calculate this ILCU well.